Hello students, today we will learn about the formation of image with the help of a concave mirror. This is the last topic in the concave mirror series. As usual, I am going to draw a concave mirror with a large, let us say, radius of curvature. Okay? Right. Now I have drawn with a large radius of curvature. The middle point of this is pole of the mirror and the center point is center of curvature, and let us join and make the principal axis. We need to first make the principal axis. Without principal axis there cannot be any diagram at all. So let us be very clear. First draw the principal axis. Fine. So this is the center of curvature and this is the point. Now half of that, let us measure carefully. It is 46, that is 23. This is the focus. The midpoint is the focus. Previously we studied that beyond C the image was forming between F and C. At C it was forming at C only. And I told you to do between F and C, you should have got an answer. Beyond C the image should have been formed. At focus it should be at infinity. Suppose if I keep an object within focus, right? So let me take an object and place it within focus. AB is the object. Within focus, how the image will be formed and where the image will be formed, which we will be doing it now. As usual, from the tip of it, take a ray parallel to the principal axis. Principal axis, right? Now, this ray after striking the mirror should pass through the focus, right? So let me keep it here carefully and let me draw and let it pass through the focus, right? Now, okay, now this is passing through the focus and I need to take one more ray. Another ray which I usually take is passing through the focus becoming parallel, but that will not work here. So we need to take the other one from the tip to the pole of the mirror. Let me join with a line. Okay, so this is the incident ray. This is the angle of incidence. If this is the angle of incidence, you know according to law of reflection, angle of incidence is equal to angle of reflection. So let me mark some angle of reflection somewhat like that. Okay, now let me draw a reflected light carefully like this. Fine, reflected light. Okay, so this is reflected back. Now where is the image? Do you think that these two rays will at any point meet anywhere? They cannot meet anywhere because they are diverging. So what we do mathematically, we extrapolate it. Extrapolate it where? I will extrapolate it behind the mirror. Watch again carefully. I am extrapolating these two rays. I keep it like this and I take it behind the mirror. Behind the mirror. Behind the mirror image cannot be real. Behind the mirror image cannot be real. It has to be virtual. Virtual means imaginary. Again I am taking it forward. Again I am extending it. Both the rays, right? They ought to meet somewhere. Let me find out where is it going to meet. Okay. Yes. It is somewhere coming close here and it is meeting at this point. Okay. Now image is formed here and you see the tip is here. So let me take the point here and let me extend here also backward. Remember, we use dotted lines because it is not real, it is imaginary. So I extend the principal axis in the backward direction. This is the principal axis. Yeah, in principal axis, you know that the ray is incident, it will reflect back, rebounds back. Right. Now this is the pole of the mirror. So the image is formed there. So what I do? I take it like this, keep it like this, and I draw perpendicular, right? Perpendicular. Look, this is the tip of it. A dash, B dash is the image. A dash, B dash is the image and AB is the object. Now, I have kept the object within F, within focus. Now, where do I get the image? I get the image behind the mirror, behind the mirror. So, whenever behind the mirror, what should be the nature? The nature of the image is, one, it is virtual. It is virtual. You can't get it on the screen. It is behind the mirror. Mirror is opaque. Fine. And it is erect. Whenever it is virtual, the image will be erect. And third point, it is small and this is big. And you get enlarged image. Enlarged image. So this is the nature. And this is where the position of the image. I hope you are very clear about it. Where do we use this mirror? You know, when you go to a dentist, dentist will wear a mirror like this with a light. And he will bring your tooth to the focus. He will bring the tooth within your focus. When he brings it within the focus, what he see is an enlarged tooth. Then what will happen? The tooth decay, or what is the problem with your tooth? All that can be identified because the image formed is enlarged image. Now this is the completion of concave mirror. Now what I want to do is one more extension of it. I hope you are very clear. It's very important concept because the object and position when you see, this is very in that way important. Okay. So now I'm going to take convex mirror. Okay. In convex mirror, we have only one case. We don't have so many cases. Only one case we have, whereas concave mirror, as forming the real image, you have the position infinity, beyond F, beyond C, at C, between F and C, and also you have at F and within focus, right? And the last topic today is that of a convex mirror. Fine. And let us see how the image is formed. First, let me draw a convex mirror. Fine. See, convex mirror. I'm going to take it from this side because reflection is taking place from there to here. Light is coming from there to here. So I take the point here, right? And I keep it here and I draw an arc. Okay? And the reflecting surface is outward. So I coat it inside. I coat it inside with lead dioxide. The middle point, you know, is called pole. Fine. Now, let us draw the principal axis. Right. So, this is going to be the principal axis. Fine. I told you, behind the mirror, virtual things are going to be not real. So, dotted lines I am going to use. Right. And this is the center of curvature because this is going to be the sphere. And I told you what is the distance it is going to be. It is 40. So, 40 I have to take 20. That is the focus. Half the value is the focus. Now, this is the pole. Let us go slow. Right. Take a ray. So, in the principal axis, a ray comes and strikes it and it will rebounds back in the same way. Now, let me take a ray parallel to the principal axis. The ray is parallel to principal axis. Now, what will happen to this ray in convex mirror? So, you know that this is the tangent I am drawing. Okay. And this is the normal at the point of incidence and the ray will diverge. The ray will diverge. Fine. Keep it carefully like this. Let us draw. Fine. the ray has diverged. Fine. Now again we need to calculate, find out where is the image formed. Where should we keep the object? So we know that this is, I have taken 40. Fine. So again this is 40. So let us mark the center of curvature here. Fine. And let us mark half the value to be the focus. Let us take an object within F and C. Okay? An object within F and C. So this is A and this is point B. A ray which is parallel to the principal axis has diverged. And now let me see that the diverged ray should come and meet at the focus. Fine. So you have to be very careful while drawing the diagram because it is geometrical optics. So be careful with whatever the calculation you are doing. Right. I have taken it. Now one line has come. Where will the other line going to be? So take a ray from the tip of it, mark it and take it like this. Fine. So this is the incident ray. This is the angle of incidence. It is the reflecting surface. So angle of reflection. Angle of reflection. Fine. Now take the angle of reflection. Angle of reflection. With that, this is the reflected ray. Okay. Now where is it going? Again extrapolate it backward. Like this. Yes, they are meeting. Again, this is the tip, A dash, and draw a normal. And this is B dash. So, A dash, B dash is the image is behind the mirror. Let me cross check few points very carefully to make the diagram a little bit clean. So, let me just remove this carefully. Fine. And I relocated it like this. Fine. So this is F, this is F, this is C. It's fine. Okay. Now this is the reflected ray. Okay. Now this is the only case. Object is between F and C. F and C. And where is the image formed? Image is within focus. Image is within focus. That is the first point. Second, behind the mirror. So the nature of the image is virtual. It is virtual. Whenever it is virtual, it is going to be erect. And in the case of a concave mirror, within focus, you got enlarged image. But here, you see the size of it and see the size of it. Size is big, size is small, and this is called diminished image. What is it called? Diminished image. So, with this, I hope you are clear. Yeah. So, in this, wherever you keep, beyond C, at C, between F and C, anywhere you keep it, always it will form within F, right? And if it is going to be at infinity, it will form at F, right? And this is what the whole relationship for the formation of image in the case of a convex mirror. Thank you so much.